So now we are ready to run our script. First, select a working directory. So I have here my folder, and I just selected this one, density estimation. I remind you, don't do double click and get in. If you want the folder, just select with one click and then select folder. And that window can appear here or can be under, or you have to reduce to icon to find it. So don't be desperate if you don't find that. Then install CtrlR, I guess you have. Install Sacred, which is easy. Just go here, package, install, and then type Sacred. And once you select, install. I did, so I will not do it again. To load both programs, which are the only two necessary in this case, I just run and run. So I loaded the two programs. And now I select the camera traps file. I call the camera chords 3. Open. Let's check it is okay through head. So I use with the head, we will have a preview of the first 6 rows. That's is showing, so the first 6 camera. As you see, there is no any problem with the column separation. So good. Now open the capture history of Snow Leopard data as I showed the matrix, and again I head to see if the file is correctly read by R. As I told you that that brackets between the name are not anymore are not read by R. So that's how you're supposed to see once you had the file. Now we try to be sure that any potential brackets or whatever can be removed. So run this script from column name. Then we give the name to the column to do a new table that basically merge the data between the Snow Leopard capture history and the camera trap. Okay, everything is running well. Now, to see in the new table, there is no empty cells, empty data with the not available and A. I make a sum of this possible NA on this table, which should be 0 because I don't want any empty cells, any empty row, because basically we didn't have any empty in our file, so not supposed to be any empty here, or it means there is an error. So from this command function here, the sum of NA should be 0. Let's see, it's 0. See here, 0. So good. Then now give some name to the column and do create the camera operation matrix. That's fine. Now we have the capture history. Basically, if it runs correctly, the model will run correctly. Let's see. Well, as you see in the time zone, I put Asia Ulaanbaatar, but you should put Asia in your country. I mean, where the data were collected. You see here the sampling occasion. I divided in 5 days the sampling occasion. So a detection for 5 days in a certain site, etc. Then we can get a summary of the capture history. Here I give some information like the number of detectors was 65, which means 65 camera traps. The average spacing between camera was 1 km 727. The coordinate space between this and this for longitude, and between this and this for latitude. Then you have to give for each occasion the minimum, maximum, some number of detection history for each occasion. And then you give the total number of detection, the number of level was not level was 10, the number of detector visitors was in total 21, 29, all this kind of information. Finally, we can plot it. As you see here, you see the cross are the camera traps, and the dot are the sites where snow leopard were detected, and the darker one correspond to higher number of detection for that site. Then we have to do a mask, which is basically establish what is the integration region. I will not go here in detail how to decide that, but later I will suggest you some book where you can refer to do your own mask to decide basically the buffer and the spacing. That's the only two parameters you have to give. Then we run. So we call the integration region the mask. And now we run the model. Run the model, as you see, is a null model. We need the special, the capture history. As you see, is a so-called null model. What does it mean? A model without any covariate, just to estimate the density of, in this case, it's not happened, but you do the Pelascat, without using any covariates. And we will go to explain later why. So we have as a detection function is the half normal distribution, the half hazard normal distribution, which is, I explained you in the presentation. What is it? Some other parameter. The as integration region is the mask, which is the one we create. So let's run the model. It is quite fast because my computer is fast first, and because the null model is also quite fast. So let's talk now about the covariate. For Pelascat, that's something I thought at the beginning. Probably a null model is the best. Why? Because first, rarely we have a high number detection of Pelascat. Rarely the Pelascat is detected in many sites. So what happens is that if I have the detection in 5-6 sites, it will be difficult for the model extract from that few value 5-6 where the Pelascat was found the meaning of that covariate on the Pelascat density, for instance, or detection probability or sigma. So the same thing is because the Pelascat, probably our sample no need to be 1,000 square kilometer to sample Pelascat. Likely 50, maybe 50 square kilometer would be enough. Okay, in that surface, that area, rarely a topographic covariate can be, how to say, can have such a high gradient to be in a model and be meaningful itself in a model. Probably the value of that covariate will be homogeneous, so we cannot do any inference on the model. So for this reason, the best with Pelascat will likely, not sure, maybe you have an area with a high gradient for a certain covariate that you can use, but generally the best thing for the Pelascat and for animals that have a little area for a population, and then also a little area you sample, or maybe a few detection, or maybe a few sites where it is detected, the best way is not to try to force the model to have a fancy model with the covariates, but to keep a null model without the covariate, or at the most insert some covariate related to the camera trap site or trap site, detector site, that you can add here or here or here. So they will tell you if it's a trap happy. It means if an animal go to come back to visit the camera. Once you visit the first time, it does more often, etc. This kind of covariate you can find on the effort 2019, anyway, in the SEC package manual for R. Some suggestion is also in the book Camera Trapping for Wildlife Research. The author are Francesco Rovero and Fridolin Zimmerman, and the editor is Pelagic Publishing. So again, last time, I will leave likely a null model or at the most using covariate like trap site covariate. No more than that. Now let's see how many snowleopard we can count for our integration region. They say 21.6. So in this case, it was easy for me make an example with the snowleopard, but it will be the same with the Pallas cat. And finally, we will give the coefficient value through predict, and we have the coefficient value of the parameters and the standard deviation, the lower and upper level of confidence. So that's it. Now, at the beginning, I thought it could be good just to give you some introduction, a presentation like I did for the special capture capture. But after all, I guess if just you replace your data with those I wrote in the matrix and run your own model to find, as with a simple model, a density for the Pallas cat in your study site will not be too bad. Next and last class will be about concurrence of species and or better occupancy of the Pallas cat, or at least of a species. So see you the next class.